So leading up to this symposium and to encourage our students to get more involved, we hosted a diversity, equity, and inclusion data challenge event. And several students worked individually or in groups and submitted their projects. And the winners were just determined yesterday. So right now I'm going to hand it over to my colleague, Dr. Christina Maitreya, and she's going to say a little bit about these data challenges and announce the winners before lunch.
Awesome. I won't keep you long from lunch. I know how that is, but I want to do justice to the participants because these were great submissions. We had the DEI challenge, and it was kind of a long process of thinking and then ad hoc putting it together. And it happened during March 7th to 9. That's when the participants worked on the challenge. They had very short time and they did great stuff during that time. So if I go to the next time, the timeline was on February 21st, we announced the challenge. On February 25 at 5 p.m. we actually close the sign up. So that's why we don't have a lot of participants, but we do have good quality participants. On March 7, the challenge details were provided. And on March 9 at midnight, they had to submit the report. So there were two options. Option one was a team challenge, teams of 3. We had teams of 2 as well. And that was looking at to score University of Michigan disease-related dissertation based on DEI criteria. And the participants had to process the text of 9,251 documents. The platform that they used was offered by ProQuest. So they have a framework where the participants logged in and they accessed the data and they did analysis. There were 3 prizes offered. First prize, $75 Amazon gift card, second prize, $50, and third prize, $25. And the prizes and the data computing were offered again by ProQuest. So this was set up to make people think of how to look for DEI-related terms in the text of any manuscript. But here we focused on dissertations. And option 2 was an individual challenge to investigate gene expression, the gene expression omnibus database, and look for data sets that are biased relative to the US population using DEI criteria, like sex, ethnicity, ancestry, and other criteria like that. Gene expression omnibus is a large database that contains data set of gene expression. And the first prize here again is $75, second prize $50, and third prize $25 offered by our department from our Rackham Faculty Allies Grant. However, we also have a sponsorship by at Bioinformatics, who offered an internship interview for the first prize and 1 free analysis on one of their tools that does pathway analysis for the second prize. And then what we did, we got the sign up. We got 3 teams, just enough for the first challenge, for the team challenge, and 8 individuals for the individual challenge. We got the submissions, and the submission was a report describing the analysis and the results. All the teams and all the individuals did a great and we had all 3 teams submit the report, and just 5 individuals submitted the report too. So there were some that didn't meet at the deadline, didn't submit a report at the end from the individual challenge. We had the panel of judges, whom I thank very much, Dr. Arvin Rao, Dr. Jilu, Jeremy, who's here, Dr. Schroeder, I, and Austin from ProQuest were the ones that looked at this and evaluated the reports. So just to talk a bit about what the participants did. So the first prize from the team challenge goes to the team formed by Catherine Barnier, Jake Schwartz, and Olivia Alge. And the project highlight, and they are PhD and master students, as you see here in our department. And the project highlights for this first prize is that they developed a word bank using online resources and personal experience that they could use to do the scoring. They used the normalized count score for the DEI related terms. And then, because they thought that's not objective enough, they trained a neural network to evaluate the DEI status of the words. And I'm going to talk a little bit more about this in a second. I want to mention the project highlights for the second prize, which is given to the team formed by Ford Hannum and Kevin Young. And then they selected a set of domain-specific terms for the 3 domains for diversity, equity, and inclusion. And they developed a score for diversity minus equity gap. So for the diversity equity gap, and this is the formula that they use. They use a term frequency inverse document frequency scoring method, and they did the difference between those for equity and diversity, and they scored the dissertation based on that. They also mentioned and had a nice discussion about the potential application for grant evaluation, for instance. For the third prize, Christopher Castro and Brad Krohn, again, bioinformatics students here, they the project highlights where they selected a set of DEI terms and calculated it, again, the term frequency, inverse document frequency metric. And then, if I could see my slide, they checked the title, the abstract, and the full text. So that was very interesting because none of the other teams looked at all of them. They just looked at the full text. They looked at the title and the abstract, and they also put a different weight. They downweighted the full text because if you have a DEI term in the title or in the abstract, it's more important. And the final score was the sum of these 3 terms. So for the first prize project highlight for the team challenge, we see that here the word frequency-based metric was functional but heavily biased, the participants say, and they attempted to correct for this in the neural network method. And also they conducted 5-fold cross-validation and achieved a prediction accuracy of 81% on the testing data set. So they didn't manage to fully use this on the dissertation data set. They did the training and they were about to remove the bias that they had, but there were some technical issues. However, the idea was great. And they also provided us here with subject terms. So they took more information from the dissertation, not only the abstract title and full text. They took the subject terms and they showed us how the subject terms of the top ranking dissertations are distributed, and the relevant terms like African American studies, African Americans, Black studies, and so on, ethnic studies. So the dissertations that were selected had relevant subject terms. And they also looked at the classes for those dissertations, and those include very relevant classes, just like African study or ethnic studies. For future work, they want to do high ranking versus low ranking dissertation and use a benchmark to follow up on this project so that they have an unbiased approach to look at manuscripts or any other type of document, rather than relying on a score that they devise based on subjective criteria. So they have here a list of the top scoring dissertation. One was attitudes about disability and political participation since the 2016 US presidential election. Multi-clinical college students understanding interpersonal self-concept, and the score was here. The top score was 0.48, and the next one was close to that, and so on. They also showed here the ratio that was used to compute the score. Next, for the individual challenge, the first prize was given to Manur, will be given to Manur Gondal, a bioinformatics student, PhD student in our department. The second prize to Hoje Lee from electrical engineering and computer science, and third prize to Zekim from chemistry. And that's a dual degree bioinformatics student. So project highlights, the first prize project developed a very thorough pre-processing criteria. So they had to take geo data sets, those data sets, and look at the metadata and figure out if there is a balanced data set between males and females or races. So they looked at that, and before they got to use that metadata, they developed a very thorough pre-processing. The gender can be stated as male, female, girl, F, or any other type of setting. So it was hard to kind of hone in on those, on that information. The same thing for race. They used the score based on the female-male ratio and the goodness of fit test p-value for the proportion of race to score the data sets. And then they displayed the results for the individual criteria and combined as well per year and highlighted the difference. And I'll show a couple of figures in the next slide. For the second prize project, the highlight is it's on GitHub. They actually put the project on GitHub, which is very useful, and others can build upon it or they can follow up. They developed a very good, thorough pre-processing, and they used kind of a probability approach to identify the sex ratio, not just a simple female to male ratio, but they use a probability approach to get a score that's a little bit more unbiased, and that's bounded between 0 and 1. And then they used the Earth mover distance for race and also looked at differences by year. And they made this nice map. They looked at different countries and they looked at the ratio per country, which was pretty cool. For the third prize, project highlights thorough pre-processing. They developed a Shannon entropy-based score for gender and race, and they had nice visualization like here, where you see actually the here the equality for the two sexes. Here you see the bias in some of the data sets. And these were the top scoring data sets. These were the mid-score data sets, and these were the biased ones that they said probably were the one that were prostate cancer or they were breast cancer studies. So last, the first prize project highlight, they encountered issues pertaining to how different research groups classify different ethnicities and genders, which I mentioned. The results, gender-only ratio shows that there are 116 data sets. So from 2000 that they started with, they had to do a lot of filtering until they got to only 116 that they had both gender and race information. So there is a lack of that type of information in our data sets. And then from 163, which are equal to and above 0.5, which is kind of not a very strong criteria, indicates that a good balance of gender, whereas 43 were below 0.5, showing gender inequality. So, and then they looked at difference per year, and after 2015, the sex ratio shows more bias compared to the ethnicity ratio, and we can see here. So this is before 2015, this is after 2015. They also look at the distribution of race across all the data that they looked at. They pulled it together and they looked at the distribution of race. And you see that definitely there is a difference between the races that in how they're represented in the data sets overall. So here they had only gender-based rank, and they got some data sets that were scored on the top 5. And then when they looked gender and ethnicity-based rank, they had a different data sets that included that information, and they had a more accurate score. So lastly, what we learned from it is that the data challenge involves many people. So thank you everybody that participated, helped, that provided advice. Thank you. A data challenge is fun. It tests the limits of the participants, and that's the purpose. In a sense, DEI-related bias can appear in many shapes and forms, and thinking about it and being involved in this type of activities can help you get your mindset in that space. There are many creative ways to look at data. You just need a reason, and this is a very good reason. So do participate in data challenges. The scientific community should work diligently to identify, acknowledge, and address the DEI-related bias in data sets and manuscripts. And last, thank you everybody, and many thanks to all participants, judges, and sponsors. Thank you. Yes. So now everybody can break for lunch. Thank you, and be back at 1 o'clock.